How's it going, guys? My name's Daniel, aka HashLips, and welcome back to the continuation of learning Solidity. Now, today we're going to look at interfaces. It's a much more complex concept to understand, but once you have the hang of it, everything in Solidity would start to make sense. Go ahead and create your myinterface.sol file and put in the base structure. Before we implement interfaces and show you how it works, I want to explain by looking at the OpenZeppelin contract repo on GitHub. We know that we've used the ERC 721 standard contract before. If we open the standard, we notice that the ERC 721 contract is using inheritance. It's inheriting from a bunch of different smart contracts. And one of the things that it's inheriting from is the IRC 721. You might notice that this looks very similar to this, but this one has an I in front of it. The reason is, this is the actual blueprint that the ERC 721 follows. And what is a blueprint? Well, let's go one step back and look at this IRC 721 contract. A blueprint is basically just an interface telling a smart contract what functions and methods it should implement in order to follow its structure. It has to implement all these functions and write executable actions for them. You notice that this IRC 721 interface has a function, but this function doesn't have an open and closing curling brace. The reason for that is this just defines how the method's signature looks like, and it's up to the person implementing the interface, implementing this so-called blueprint, to implement each one of these methods. Why is it important for us to have interfaces? Well, let's take an example. OpenSea expects a ERC 721 contract to have these different events, to have a balance of function, to have an owner of function. And when we tell our smart contract that we have to inherit from this, the program and Solidity compiler will make sure that we implement each function so that it will work. If we don't, it will simply give us an error and it won't compile the code. Let's go look at an example where we can create our own interface looking like this, and what's the rules regarding interfaces. If we jump back into Remix, we can now start off by creating our own interface for our myInterface contract to inherit from. And let's see how can we define that. In order to implement an interface, there's a few rules we have to follow. Firstly, let's go and create our interface, our blueprint, here at the top before we declare our function. Interfaces, like you see, don't have to exist in the same contract file, but we are going to define it here so we exactly know what we are doing. You start off by typing out interface. This tells the compiler that this is an interface and it has certain rules going with it. The few rules that an interface carries is that it cannot have any of the functions that we define in it implemented. It means that we cannot define bodies to our functions telling it how it should behave. We can only write the signatures. Let's go ahead and give our interface a name. A good convention to follow is starting with an I, and let's call this our counter interface. We are just going to say this is a counter, and we open our curly braces like so. Now we can define the blueprint of our counter interface. So we'll call it the iCounter. Let's say our counter's blueprint should definitely implement a count function. So how can we define this? We're going to define it by typing in function, creating a normal function. Let's call it count. And our function will have everything that a normal function has apart from the body. So we have to make this external. So we have to say that this is an external function. It has to come from outside the call. So then we also can make this view, and we can say that this particular method signature, this function should return a type of value. So we want this to return to us a UN256. Once you've declared a function like this, usually you would go and open the braces, like so, and start implementing it. Solidity will pick this up and complain and say you cannot do this. This is breaking the rules of an interface. Now, interfaces can also inherit from different interfaces. So we can have an interface before iCount and maybe call it iNumber and then inherit from it here. The other thing that is very important is that all declarations of functions must be external, like we have over there. The reason is because the calls come from the outside. An interface can also not declare its own constructor, like a normal contract can. And you can also not declare state variables. Perfect. Now that we know what this is, our blueprint, let's go and add another piece of the blueprint. So we can basically have a count, which basically starts with a count and it's going to return to us a UN256. But maybe we also want another function, say add count or add to count. Let's say we want to define another blueprint method that we want to expose, and we're going to also call this a view. It's going to return nothing. This is not going to return anything. Basically, this just needs to be implemented so we know that we are going to increment our count. It can't be view because we're going to be, changing data, but our blueprint states that it needs a count function and it needs an add to count. So if we implement this interface here by inheriting from it, so we use the is keyword and we inherit from this counter interface. Solidity is going to tell us that we need to make sure that we implement the add count. So you can see over there in the error, it wants us to implement the add count and the count variables. How do we do that? Well, now we can go ahead and actually implement it and make sure that we abide by our blueprint's rules. So in order to make our smart contract work, we have to now implement it. Now let's create a UN256 and let's call this our counter. We're just going to create a counter so that we actually have something to work with our interface as well. Then we know that we need this count function and we also need the add count. We can basically copy this and paste these two functions in here and start defining them. Let's go and create a space and comment out this one just for a second and start working with our function. So basically this function needs to return a UN256. So what are we going to return? We are simply going to return this counter. All right, and that's it. Now we have implemented this interface. What we can do now is actually look at what this error is so we can see, and it says override. So it wants us to override this, and I'm not sure why it would like us to overwrite it, basically because we're implementing it. So let's type override and let's make sure it's not complaining and it's perfect. I would like to put the override maybe after the view over there. Next, we can see that we still need to add our add count down there external function, which is this one. We're going to follow the same rules. We're also going to overwrite this so that we make sure we implement it correctly. And then what should add count do? Well, the interface doesn't explicitly say it needs to return something, but we need this to be implemented. You can always leave a function empty like this, but it won't bring you any value. You sometimes want to leave it empty, but sometimes you need to add something in here to make sure that our program, at least does something positive. So I'm going to increment this counter. By doing this, if we go now and deploy our new smart contract, we can go and deploy the my interface, which now inherits from iCounter, And if we deploy it, we are sure that our contract will always have an add count and a count function. And this is important because let's say someone else needs to implement our iCounter interface. We are assured that they are going to implement these two functions, and the functionality is up to them to execute it. But we at least know that these functions will exist for our program to call. And that's exactly how the ERC 721 and the IERC 721 interface works. It's a promise to tell the front end, or to tell the person who's working with that smart contract, that these methods will indeed be there. Let's go and test them out. We can see our count is 0, and we can go and increment our count, and we can see it working, and it's implementing an interface. That's the basics of interfaces, and as long as you understand this, you'll be fine going forward working with Solidity. In the beginning of the course, I touched on a variable called address. If you remember, address we assigned to, let's say, my address, and I told you that this address can be an address looking like a normal wallet address. That is true, but I touched on the payable clause, which means if we add this payable attribute, this my address will actually be able to receive Ether. And that's the only thing you need to understand about payable at a top level. You need to understand, in order for an address, a function, a constructor to receive Ether from a transaction and actually then transfer it to something, it needs to be marked as payable. If this is my address and I want to be able to receive Ether into my address later on, we can mark it as payable now and make it public so we can just see it on the outside. We can then also instantiate it directly over here on our smart contract, or if we have a constructor that we want to implement, we can create a constructor and let's set my address to actually the address message.sender. Message.sender, remember, is the global address. Now, because this address is marked as payable, we have to typecast this in to a payable object. It means that this address is of type payable, so we have to explicitly say that this address is going to be of type payable because we are assigning it to this address. You can also make constructors payable. The reason why you would want to make a constructor payable or a function payable is if you are actually sending Ether to the constructor to do some extra functionality in the smart contract itself. Next, you can also add payables to functions. Let's say we have a function and we're going to call it deposit, and we want to deposit some Ether to someone's address. We can make this function public, and let's do this. Next, we can go ahead and actually go and transfer something. So let's say that we want to deposit some money when we call this function. We want to deposit to the message.sender. So we can now say the message.sender, we're going to use this, and we actually want to wrap this around a payable clause or function, and then we want to say .transfer, and we're going to transfer, I don't know how many ethers we want to transfer to this person. You will see that this is perfectly fine. We can do that because this function is not accepting a ether to do it. It's basically doing it from the smart contract itself. But let's say this function needs to actually accept Ether. So let's say we are working with the message.value object, and we want this message.value to be transferred to this contract. We need to specify on the function itself over here that this is a payable function. Just keep that in mind. And if you run into errors where you are transferring around Ether and the compiler says something that it needs to be marked as payable, at least you know what we are busy referring to. In a nutshell, if you declare a function as payable and you send some ether with this transaction, it will be actually saved in this smart contract instance, in this smart contract wallet. Later on, you can withdraw the smart contract funds, or you can work with it in some way. But let's see what happens when we send ether to a smart contract where the function is payable. Now, we're going to leave this as is. We're not going to declare anything in the body because as soon as we send a value, it will save it. Then what we can do is create another function and maybe call it get this contract's balance, like so. We're going to say this function is public and we want it to return something. So we're going to say this returns a uint 256 for us. Inside of this function, we have the global object this, which refers to this smart contract. And explicitly, it refers to the smart contract's address. Now, to get the uint 256 value of the amount of ether that this address has, we can go and type something like, let's go and get the amount. Remember, this is a memory variable, just so that you know. And we're going to say, well, we want this amount to come from this address, which we need to put in brackets and typecast to a type of address so we can work with it. This address has a special function that we can call, which is balance. Okay, so we want to know what this address balance is, and that's going to save in the amount. Then all we need to do is return the amount. This way, we will get to see what this, how much ether, does this contract have. We need to actually make this view, and there we go. This is kind of a nice example of how you work with payable attributes on functions and variables and so on. Just remember, if something receives payments in ether, you have to mark it as payable, whether it's a function, whether it's an address that you specify, and even if it's something that you pass in here. So for instance, if we had an address and we say user address, and this user address, what we're going to do with it is pay the user, we need to mark this as payable. That's just an example. Anyway, I'm going to take this out. I'm going to save it. I'm going to go to the deploy section, and here you can see that our deploy button is now red. Why is that? It's red because off the bat, if we give this ether values like so, and we go and deploy this, our smart contract will already have one ether in it because on the deploy constructor, we have a payable flag. If not, this will not be taking any ether at all. So we're going to deploy and go ahead and deploy it. And right off the bat, we can probably get this address's balance. If we click on it, you can see exactly the way amount in ether that this contract has. Next, we can actually go ahead and go and deposit some money. So what we can do is, let's give it another 4 ether. When we click deposit, and we say get this contract's address, we see that this thing has now 5 ether basically, and this is the amount of way that it has. We can also see that my address, this address, is set to the deployment address over here. Now you can also then write a function to get this ether out. If you do not write a function to grab this ether and get it out of the smart contract, you might have some problems because there's no way then to get this out. Anyway, by looking at the payable clause that you add to variables and constructors and functions, you kind of can get a rough idea how it works and how to implement something where we need to actually transfer money into someone's account, get balances, pay the contract, and so on. I hope you're enjoying the course so far, and we'll continue to explain more Solidity concepts. One concept I want you guys to understand is how transactions work. We send a transaction with data and sometimes with ether attached to it to the smart contract. Usually that data tells the smart contract what to do with that ether, pointing to a function that can be executed. But what happens if there's no data specified? How do we handle anything then in the smart contract? Usually the smart contract will just break, revert, and not execute anything. But what happens if we really want to save that ether, if we want someone to actually be able to pay in that ether without calling any of these other functions? We have two functions for that, and those two functions are receive and fallback. Both receive and fallback don't have the function signature in the front like other functions, and they all have to have the external attribute on them, as well as payable if you want them to receive ether. They both do the same kind of thing and are similar in nature, but they have different reasons for when they are going to be called on a smart contract. Receive will be called and its body will be executed once a person makes a transaction to the smart contract without including a data body, without including any data. If the data field is missing, that's when the receive function will be called. Fallback, on the other hand, will be called if the data was specified. For instance, let's say I wanted to call this function, but let's say in my front end I misspelled this function or something happened, and then it can't pick up this function in the API, the data doesn't match, whatever the case might be. There is no way for this function to execute because it can't find a function. But the data was included. Then fallback will be called. So both do the same thing. They accept ether into the contract, and then you can work with it. Keep in mind, these two functions both have limited gas to work with, so you can't do major operations inside their bodies to work with that amount that comes in. It's generally best to add this safety net if you want people to be able to pay ether into your smart contract and then execute some kind of function with it. You also have to remember, if you do this, very important, if you do it like this and you don't have a withdraw function on your contract, the ether will be lost forever, stuck in this contract. You'll have to add a withdraw function. That being said, generally it's not really necessary to put these in if you do not expect to handle payments coming into the smart contract. If you want to put them in for safety nets and then have a withdraw function so you can withdraw it, then that's also fine. It's all up to you, and you can read more on it on the documentation. On a side note, this documentation, and explicitly this part of the documentation where it says contract, is a great way for you to reiterate everything that we've talked about. It explains everything in detail, so go and take a look at it as well. But let's carry on with our video, and let's carry on with our tutorial. Next, I'm going to show you how to send transactions in a few different ways. Let's now have a look at how do we send ether to an address. There's three different ways of sending ether. You can use transfer, send, or call, and we have to look at the three different ways and which ones are recommended to use. We now know how we can accept ether in a smart contract by adding these two fallback, receive, and fallback functions. And remember, receive will kick off when there is the no data field, so if the message.data is empty, and fallback will be called if it can't find any of the functions, and also if the data was there. But anyway, let's go ahead and actually put in this function. I'm going to call this transfer ETH, and I'm going to add a parameter, address, make it payable, and call it user. Also, this function is going to be public and payable because remember, if we are sending ether, it means that this function will receive ether as well through the person doing the transaction, and then we are going to transfer it to another user, and we're going to send exactly the value that we have sent. If we wanted to transfer the ether into this contract as well, we could have probably used this. So it means instead of the user, we could have probably typecast the user. Instead of using that, we could say that this was a payable this. In this case, we can see that we can remove the variables over here, obviously, because we're not going to use it. But this function will immediately pay the ether into this contract as well, if we use that function. But we are going to just send it around to a user. So we are going to say underscore user, which is already of type payable address. And that's one way we can send ether. Another way is the send method. Now, the send method is quite interesting. It works the same as transfer, but transfer and send are the ones that's least recommended to use at this current instance of Solidity. So let's just do the send, and I'm also going to change my method name into send. All right. And then when you use send, what we're going to do is send returns to us a Boolean. So we actually have to assign this to something. So let's make a new variable and call it bool. And we can just call this did send. And then once we have it like this, we're actually saving this now in this Boolean. And if you are struggling with formatting your code, trust me, I understand. Remix doesn't do a great job of that. But anyway, then what we can do is we can actually make sure that we've sent, right? So we can put a require that this did send, all right? You guys have read about require statements. We actually have to handle it with the send method. So this is another way you can send. And obviously in your require statement, you can add something like this failed to send. All right. You can do something like that. But the third way, and the now preferred way of sending ether, is to use the call method. So how do we use the call method? So a call method is we can just specify a different function name over here, call it call. Everything stays the same. We have to have it payable as well. But in this case, we are not going to say user.transfer. Instead, what we need to do is also capture like a Boolean, but this time the call method returns to us more than one variable. So we actually have to kind of capture that. How can we do that? Well, you can specify that this function call is going to return a did send, right? Well, I just call it did send. You can call it anything to check if it was successful. Then what you can also get back is bytes. And this is of type memory, and we can just call this data. This is going to be equal to if we sent the user through the call method. So we can say, well, call. And then how you specify call is you just open these curly braces and you pass in what the value should be that we are sending. So the value is going to be message.value, like so. And then you open and put empty curly braces in there. Empty braces with an empty string. After this, all you need to do is you need to say, well, we require that it did send, okay? And that's the check you can do. And then you can also work with the data. So what you then can do is check if the data is there. If not, otherwise you don't have to extract the data as well. You can just omit it by leaving a comma like so. And that's the three methods of sending ether. You'll see a lot of people still use transfer because it's just the most easiest way, but each one of these ways would work to send ether, and I just wanted to explain that to you guys too. Let's carry on to the next section. This will most probably be in the next video, so stick around for the next video.